Watch a ROS2 robot build a map of its world in real time, just from LiDAR scans. SLAM means simultaneous localization and mapping. The robot figures out where it is and what the world looks like at the same time, using only its LiDAR and wheel odometry. Our robot is the same differential drive base from the LiDAR tutorial. We drop it into a walled gazebo world with rooms, corridors, pillars, and crates, so there are plenty of features for the scan matcher to lock onto. We configure SLAM_toolbox in online async mode. Map frame, ODM frame, base footprint, scan topic/scan, resolution 5 cm, max laser range 12 meters, and loop closing turned on. In the launch file we bring up the robot, the gazebo world, the ROS bridge for clock, CMD-vel, odometry, scan and TF, and finally the async SLAM toolbox node loaded with our parameter file. In RViz we set the fixed frame to map and add a map display subscribe to /map, plus laser scan, robot model and TF. The map cells fill in live as the robot drives. To run it, 3 terminals. Bash run.sha launches Gazebo, the robot and SLAM toolbox. Bash RViz.sha opens RViz. Bash drive.sha starts the keyboard teleop. And there it is. As we drive around, the grey occupied cells snap onto every wall the LiDAR sweeps over. The dark unknown region shrinks with every room we explore, and when we close a loop, SLAM toolbox pulls the whole map into alignment. When the map looks good, bash save map.sha writes a PGM image and a YAML file to disk. That same map can be fed straight into nav2 for localization and path planning in the next video. Full code is on GitHub, link in the description. Subscribe for the next ROS2 tutorial where